This video is about freefall. Freefall is a situation that we're going to come across quite a bit, and it's a broad term. It's just for any object that is experiencing only acceleration from gravity. Near the Earth's surface, this acceleration has a magnitude of 9.809 meters per second squared. If we want to write that as a vector, if we say that vertically up is our positive y direction, and maybe horizontally to the right is our positive x direction, so kind of standard coordinates set the way we're used to seeing it, then our acceleration is going to be 9.809 meters per second squared in the negative y, in the downward direction. Gravity goes down. This is a value that we use so often that we give it its own letter designation, g. So g is going to be that 9.809 meters per second squared. I'm going to point out g is a positive number, it's just the magnitude, so that my acceleration can be negative g in the y direction. Later on, when we start doing forces, there's always some kind of a question of when do we put in a positive g, when do we put in a positive number for g, when do we put in a negative. We're always putting in a positive number for g. We are just saying the direction of the acceleration is in the negative y direction. That's where we pick up that minus sign. 9.809, that's not a number that is particularly nice to carry around and throw into a lot of equations. In a real-world situation, we also have to deal with some things that we ignore in this course. Air resistance, wind currents, other small fluctuations, things like that. So it is perfectly reasonable, actually, to round this to 10 meters per second squared. Depending on how particular you as an individual are, this might bother you. If you are taking this course on the way to applying to med school, grad school, dental school, anything that requires a standardized entrance exam, including, by the way, graduate school in physics, these standardized entrance exams, they all round that gravitational acceleration to 10 meters per second squared as well. If you are going into engineering, by the time you throw in safety factors, the difference between calculating these things with 9.809 and 10 doesn't show up anymore. So 10 meters per second squared is what we're going to use for the duration of this course. Freefall. We have been doing quite a bit of one-dimensional motion, and really freefall is going to be easier than other one-dimensional acceleration problems, and that's just because the acceleration is always the same. The trick to freefall problems is just recognizing when you can use that g acceleration, because it's not often stated. If I am standing at the top of a building and I lean over, maybe with the other hand I'm holding a rope so I don't fall. I lean over, I take a ball and I drop it. Then if I were to set up my table, it would look like this. Y initial, Y final, V initial, V final, acceleration, time. Let's say down here at the ground, I can call this y equals 0. I can start out at some position, maybe 20 meters. If I'm setting up my table, I'm dropping this thing from rest, so I'm starting with an initial velocity of 0. I don't know what my final velocity is when I hit the ground or anything like that. I don't necessarily know how long it's going to take to land. I know I'm not asking a question here, so understand that we can adapt this to different questions. My y final is going to be at y equals 0. My y initial, I'm starting 20 meters up. My acceleration here, I'm not told what my acceleration is. I'm just told I'm leaning over the side of a building and I'm going to drop something. As soon as I let go of that ball, This is now in free fall. The only thing acting on it is gravity. My acceleration is going to be -10 meters per second squared. The next video is going to work through some examples, but for now, this is the idea of free fall.